Well, I came up with a metric I call Standardized Calibration Adjustment Index, and I don't want to get too deep into the statistical weeds. But what this does is it boils the difference between the respondents and the population down into one number. And you calculate your design weights, in this case, with the simple random sample assumption for RICS. In an outbound telephone, you might have strata and disproportional stratification. You could account for that in the design weights. And then the analysis weights are the weights where you calibrate the design weights of the population total. And so what the SCAI, or the Standardized Calibration Adjustment Index, is simply the sum of the absolute value of the difference between the design weights and the analysis weights over the sum of the analysis weights. And then you multiply by 100. It's what percentage did you have to stretch the weights? What percentage of the total weights? So you divide by 2 because when you change the weights, some get bigger, some get smaller. So you're double counting the stretching of the weights. So the more you have to change the weights, the more off your sample was from your population. And it has a very nice interpretation if you simplify. If you calibrate it to one distribution and had 2 levels like sex, and in this example, there's 50% male in the population. If your design weights had 30% males, then your SCAI would be 20%. So 20 or 20, the 20 is the percentage you had to adjust your weights to make it match up. So that gives you a kind of heuristic to understand what's going on here. So now I'm going to apply that SCAI measure, but I'm going to look at 3 different types of surveys, and each one I have 3 different studies. So the one in orange on top, that's all the New York State Adult Tobacco Survey, and this was done with an ABS frame. ABS stands for Address-Based Sample. So this is a frame of all the addresses that the U.S. Postal Service delivers mail to. And then the mode, PAPI stands for Paper and Pencil Interview. And then we had web and PAPI, we did both. And then we calculate the SCAI and take the average. So for the ABS, the average SCAI is 26.6. So you miss your population because the people who respond to mail surveys are different. They tend to be higher educated and older and more female. So now we look at the blue 3 studies. Those are the outbound telephone surveys with CADI data collection. And here, when you average the SCAI, you get 18.5. Now, the purple are the 3 RICS surveys. So this includes the assumption that there's a simple random sample. Now, if that was false, certainly it's not 100% true, but if that was causing a lot of bias, we wouldn't expect the respondents to look like the population. Now, remember, this isn't like web panels where they're using quotas to force it to look like the population. This is organically what we get from the sampling procedure. So the average SCAI is 20.5, which is a little bit worse than the outbound telephone survey, but quite a bit better than the ABS.